Jagannath, and this is my Physics 2212 Lab 1 report. So the main purpose of this lab is to determine the excess charge on a charged piece of tape and observe the interactions between two pieces of charged tape. The physics principles I used were Coulomb's law, which defines the electric force between two charged objects, charge 1 times charge 2 over distance squared times this constant k, and the gravitational force on an object, which is equal to the mass of the object times gravitational acceleration, and also the principle that like charges repel, opposite charges attract. The result I ended up with was that the tapes are positively charged and have a charge of approximately 1.87 times 10 to the negative 9 coulombs. In order to charge a clear piece of tape, I stuck one piece of tape on top of another and ripped it off really quickly, as this model shows. My expectations were that two U-tapes would have the same charge since I made them the same way and therefore should repel one another, which is what happened, and the U-tape was attracted to neutral objects and a negatively charged object, which made it positively charged. So this was the model that I used to observe the interactions between the two U-tapes. As you can see from the free body diagram, the main components of the main Y components of the force on tape B are the electric force and gravitational force, and since the magnitude or momentum of tape B rather is not changing, the magnitudes of these two forces have to be equal and opposite in direction. And then to determine the gravitational force on tape B, you need to find the mass of the tape. And then some assumptions I made were that each U-tape has the same charge since they were made the same way, and each U-tape is one point charge located in the center of the tape. I also ignored other outside forces like air resistance. Some measurements: the length of the tape was 0.2 meters. The separation between the two tapes was 0.004 meters. And the mass of the tape, which I used the formula 1 gram is equal to 1 meter of tape, I got 2 times 10 to the negative 4th kilograms. I used that to figure out the gravitational force on tape B and then set that equal to the magnitude of the electric force on tape B. And then I was able to figure out what the charge of the tape B, charge on tape B was. And then using that, I was able to also figure out the deficit of electrons on the tape, which is 1.17 times 10 to the 10th electrons. And then you can use that to figure out the number of atoms on tape and then the ratio of electrons lost per atom. So the code, the two main functions that I defined here were for the electric force and the gravitational force, using the same formulas as I used earlier, and I got the same result, 1.87 times 10 to the negative 9 coulombs for the excess charge on tape B. And then the what if electrons had a positive charge and protons had negative charge. This would not change any observations since the principle that like charges repel and opposite charges attract is the same. And then why is it important to handle the charged tapes as little as possible? Because if you do handle them, then it could cause more of electron transfer between the tape and the hand, which could change the charge on the tape. And then some sources of error. Mass of the tape, as I said earlier, I used that formula, is an approximation. And then additional outside forces like air resistance are ignored. The charge on the tape is treated like a point charge, where it's actually more spread out across the tape. And then some charge could have been transferred to my hand since I was naturally handling or manually handling the tapes. And so overall, the result I ended up with was that the tapes were positively charged and they have an approximate charge of 1.87 times 10 to the negative 9 coulombs. Thank you.